I'm going to explain the Scikit-Learn's MultiTaskLasso model. It's a powerful tool for handling problems where you need to predict multiple things at once. Think of it like this: instead of having separate models to predict house prices, stock prices, and the weather, we use one that's super efficient. We have a dataset with 100 examples. Each example has 5 characteristics, features, we'll use to predict 3 different things, target variables. For example, features could be size, age, location, etc. of a house, and target variables could be the house's sale price, property tax, and estimated rental income. Scikit-Learn is a Python library. The MultiTaskLasso is a specific type of model within Scikit-Learn that handles multiple target variables. It's a linear model, meaning it looks for relationships that are straight lines, and includes a special technique called L1 regularization. The question focuses on the _koa_ attribute, which holds the results of the model, the numbers that tell us how much each feature influences each target. We need to figure out the layout of this attribute and what each number means. This option gets the dimensions wrong. It incorrectly suggests that we're organizing the information by feature then target variable. This is correct. It presents the coefficients, neatly organized with each row representing one of our 3 targets, and each column representing one of 5 features. This is incorrect. The _koa_ attribute doesn't store the intercept terms. It's all about the coefficients that show how features influence the targets. This is correct. L1 regularization is a technique that helps to make the model simpler and more interpretable by forcing some coefficients to be exactly 0. Our dataset consists of 100 samples, rows, with 5 characteristics, columns or features, for each sample. We're trying to predict 3 different things using our model. The _koa_ attribute contains the model's results. The numbers tell us the strength and direction of influence of each feature on each target. I'm analyzing the shape and meaning of the _koa_ attribute, which holds the model's coefficients. It's key to understanding how MultiTaskLasso works. The _koa_ attribute is a 3 by 5 matrix. This means we have 3 rows and 5 columns. Think of it like a spreadsheet. Each row represents one of the 3 target variables you're trying to predict. Each row contains the coefficients needed for that particular target. Each column represents one of the 5 features used to make predictions. Each column shows how much each feature influences all 3 target variables. MultiTaskLasso uses L1 regularization, lasso, which encourages sparsity. This means some coefficients within the matrix might become exactly 0 during the model training, simplifying the model. Because of the L1 regularization, some of the numbers within the 3 by 5 coefficient matrix might be 0. This is great because it helps simplify and possibly improve the model. I'm analyzing the coefficients from a MultiTaskLasso model. This model is used for multi-output regression problems, where we predict multiple target variables simultaneously. Think of it like predicting both temperature and humidity based on several weather features. I have 100 different weather observations, samples, in my dataset. Each weather observation includes 5 different measured values, features, like wind speed, pressure, and humidity. I'm trying to predict 3 different things: target variables, temperature, humidity, and air pressure. I'm using a MultiTaskLasso model from the Scikit-Learn library in Python. This is a special type of linear regression model that is designed to handle multiple target variables efficiently, applying L1 regularization, lasso. The _koa_ attribute stores the learned coefficients of my MultiTaskLasso model. These coefficients tell me how important each feature is for predicting each target variable. The shape of the _koa_ attribute is 3, 5. This means it's a 2-dimensional array with 3 rows and 5 columns. Each row represents a target variable, temperature, humidity, and pressure, and each column represents a feature, wind speed, pressure, and so on. The specific values in the array are the coefficients themselves. They indicate how strongly each feature contributes to each target variable. A large positive value indicates a strong positive relationship. A large negative value indicates a strong negative relationship. and a value near 0 indicates a weak or non-existent relationship. This question asks you about the shape and meaning of the coefficients that Sklearn's MultiTaskLasso model gives you. We're dealing with a multiple regression problem, meaning we predict 3 things at once using 5 features and 100 examples. The key is to understand what the _koa_ attribute will look like after training. Let's break down the dataset. I have 100 different examples, rows, in my dataset. Each example is described by 5 different characteristics or features, columns. I want to predict 3 different things, target variables, for each of those 100 examples. For example, think of predicting house price, size, and number of bedrooms based on 5 characteristics like location, age, etc. I am using MultiTaskLasso, a machine learning model from the Sklearn library. This model is specially designed to handle multiple target variables at once and uses a special technique called L1 regularization, which makes some coefficients exactly 0, leading to a more compact model that simplifies interpretation. The _koa_ attribute is where I find the model's learned coefficients. Coefficients tell us how much each feature affects each target variable. Since I have 3 target variables and 5 features, this attribute is going to be a 3 by 5 matrix. This shows the dimensions of the coefficient matrix. It's 3 rows and 5 columns. This means that each row shows the weights for the 5 features of one of the 3 target variables. Each column shows how each feature affects the 3 target variables. In other words, it's the weight matrix from the model. This is wrong. The intercept terms, the values when all features are 0, are typically stored separately, often in an _intercept_ attribute, not _koa_. _koa_ is just for the weights of the features. This is correct. The shape 3, 5 is what we expect. 3 target variables, 5 features. Each row gives me the coefficients for one target variable, showing how much each of the 5 features affects it. This is also correct. L1 regularization, Lasso, is famous for making some coefficients exactly 0. This helps simplify the model and makes interpretation easier because it performs feature selection. Our dataset has 100 individual examples, each with multiple measurements. Think of each one as a separate person's medical record, or a separate house's data for property value prediction. Pretty standard stuff. Each sample has 5 different pieces of information we'll use to make predictions. These could be things like age, height, weight, blood pressure, or square footage, number of bedrooms, etc. We're using these features to predict things. We're trying to predict 3 different things using these features. For example, maybe we're predicting cholesterol levels, blood sugar, and blood pressure. Multitasking with the model. This is the type of model I'm using to make all those predictions at once. MultiTaskLasso is a special kind of linear model that makes multiple predictions simultaneously, using a technique called L1 regularization, Lasso, to keep the model from getting too complicated. This is important for our quiz. This question is asking about the array of numbers that represents the relationship between our features and our predictions. Understanding the shape and meaning of this array is key to understanding how the model is making predictions. Let's break down the options. This is the correct answer. The array will have 3 rows, 1 for each thing we're predicting, and 5 columns, 1 for each feature used to make the prediction. Each row tells us how much each feature affects the prediction for one specific target variable. Think of it as a table. Also correct. L1 regularization, or Lasso, helps keep the model simple by making some of the connections between features and predictions exactly 0. This means some features will be ignored by the model for the predictions. This is incorrect. It gets the rows and columns switched. Remember, each row should represent a prediction target. This is also wrong. The intercept is a separate thing. It's a starting point for the prediction that's not related to the features. The question asked for the coefficient, not the intercept. I'm analyzing how Sklearn's MultiTaskLasso handles coefficients in a multi-output regression problem. This is all about understanding the structure of the results it gives us. We're figuring out what the _koa_ attribute means after fitting a MultiTaskLasso model. Specifically, what its shape is and what each number represents. We're using a machine learning tool called MultiTaskLasso from the Sklearn library. This tool is designed to predict multiple things at once, multi-output regression. Think of it as predicting several related outcomes from a single set of data. We have 100 samples, data points, 5 features, the things we know about each sample, and 3 targets, the things we want to predict. This statement says the coefficients will be in a 3 by 5 matrix. Each row represents a target, and each column represents a feature. This means each target has its own set of 5 coefficients to weigh each feature in the prediction. This is correct! I have 100 different examples of data, each described by 5 characteristics or features. I want to predict 3 different things from this data. This attribute contains the numbers the model learned. They determine how much influence each feature has on each prediction target. The _koa_ attribute is a 3 by 5 matrix. It's a rectangular table of numbers which is really important to understand. I have 3 rows because I have 3 target variables to predict, and I have 5 columns because I have 5 features influencing those predictions. We're investigating how Sklearn's MultiTaskLasso handles multiple target variables in regression. Specifically, I'll explain what the "coef" attribute reveals about the model's learned coefficients. It's all about understanding the shape and meaning of this matrix. This is the core problem. We're using Sklearn's MultiTaskLasso to build a model that predicts multiple outcomes, 3 target variables, using 5 input features. After training, how do I interpret the shape and meaning of the _koa_ attribute? The "coef" attribute holds the coefficients learned by the model. These coefficients link the input features to each target variable. It's not just one set of numbers, it's a matrix, a table of numbers. Its size and organization are what I'll explain. This shows that the "coef" attribute has 3 rows and 5 columns. That means each of the 3 target variables gets its own row of 5 coefficients. 1 coefficient for each of the 5 features. Think of it as a table where each row is a target variable, and each column represents a feature's impact on that specific target. I'm using MultiTaskLasso, a type of regression model, to predict multiple things at once. Crucially, MultiTaskLasso uses L1 regularization, lasso, which makes some coefficients become exactly 0, making the model simpler. It's a linear model that efficiently handles multiple target variables. The L1 regularization, lasso, helps by making the model less complex by setting some coefficients to 0. This is important for feature selection and avoiding overfitting. I'm trying to predict 3 different outcomes simultaneously. This is a multi-output regression problem, meaning my model learns to make 3 different predictions for each input sample. That's why I have a separate set of coefficients for each target variable. I have 100 different data points, each with 5 features and 3 target variables. This is the data that my MultiTaskLasso model is trained on to learn how the features relate to the different target variables. My data is structured with 100 samples, which is typical machine learning jargon for data points. Each sample has 5 features that are used to predict the 3 target variables. This statement is incorrect. The intercept terms, the values when all features are 0, are usually found in a separate attribute, often called "intercept". The "coef" attribute focuses solely on the coefficients for the features. This is correct. L1 regularization, lasso, is known for its ability to create sparse models. This means the model can set some coefficients to 0, effectively removing some features from consideration, improving the model's simplicity and generalizability. This is the correct interpretation of the "coef" attribute's shape. Each row is linked to one target variable. The values in that row give the influence of the 5 features on predicting the values for that target variable. This is incorrect. It reverses the rows and columns. The structure is such that each target variable has its own coefficients for all the features.